Hey everyone, so today I want to take a look at a distinct triangles question. So this question here says, given the figure shown, how many distinct triangles can be formed? Alright, the way we're going to approach this is by using the law of sines here. So that said that the sine of angle A over side A equals the sine of angle B over side B. So in this case I could write it as the sine of angle, I'll label this A, let's say this is B. C. Okay. So sine of 43 over 5 is equal to the sine of angle B over 7 in this case. So I want to figure out what angle B is, so I'm going to multiply each side by 7 here. So we get that sine of B is equal to 7 sine 43 over 5. Which you can do this in your calculator here. Just make sure that your mode, when you do this, is in degree mode and not radian mode. That's going to make a big difference. So if I were to type this in, 7 times sine 43 divided by 5, that gives me roughly 0.95. Roughly 0.95. I suggest using the entire answer your calculator gives you here when you're doing this out. So to solve for B here, then we take the inverse sine or arc sine of both sides. So we want to know what the arc sine of that 0.95 decimal is here. So we'll get B equals, and I'm going to go here and type that in. So here we get the arc sine of our answer from before, and it will give us 72.7. So I'm just going to round that to the nearest tenth. I'm going to say 72.7 degrees for angle B here. Okay, so that would be 72.7. And then we know that a triangle adds up to 180 degrees. So we're going to do the 180 degrees minus the 72.7 minus the 43 there, and we'll get 64.3 as our last angle. So this tells us that we have at least one. So at least one triangle, because we just found it right here. The question is, are there more triangles? Well, if you'll notice at this step right here, it said sine B was about 0.95. And if you remember what the sine curve looks like, so the sine curve looks like this, where this is 90 degrees, this is 180, this is 270, and this is 360 here. And the max value there is 1, and the min value is -1, so you have 0. So if we were talking about 0.95, that would be somewhere really close up here. So 0.95 would hit our sine curve at this spot, and it would hit our sine curve at that other spot right there as well. Now, both of those are less than 180. This also comes true from the fact that, if you remember ASTC, in the second quadrant sine is positive and the first quadrant sine is positive. So when it says sine B equals 0.95, that could happen in quadrants 1 or 2. So when we got the answer 72.7 degrees, that was for quadrant 1. So what we need to do is figure out, well, what is that in quadrant 2? So we use the 72.7 as our reference angle to determine how many degrees this angle would be in quadrant 2. So simply here we just need to do 180 minus the 72.7, and then in quadrant 2, so we did the 180 minus the 72.7. We wind up with 107.3. So that would be our second quadrant angle here. So now if I were to redraw that triangle ABC here, so we had that angle A was 43. It says now that angle B could also potentially be 107.3. Well, we know that all the angles in a triangle have to add up to be 180 degrees. So if I go ahead and I add those together here, the 107.3, and we add that with the 43.0 here, you're going to see that this comes out to be 150.3 degrees, which means that this last angle could be 29.7 degrees, because that would get us to 29.7, because that would give us to 180 degrees in this case. So it's possible that angle B could also be the 107.3. So in this case, at least one, and we were able to get a second one. So that would tell us we get two distinct triangles in this case. All right, hope that makes sense. If you have any questions, leave them in the comments below, or again, feel free to shoot us an email at beyondthetest@gmail.com. Have a good one.